Welcome everyone. Let's begin our lesson for today by going over our learning goals and success criteria. First, let's talk about what we're learning. We're learning how to recognize patterns in number sequences and how to determine the factors of composite numbers. How are we learning it? Through the locker problem notes and the locker problem assignment. When could you use this? To divide a check at a restaurant among multiple people? How do we know we learned it? By getting a score of 4 on the locker problem assignment. Now let's take a look at our agenda for today. We'll begin by going over our learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. Then we'll go over our raffles for this week. Then we'll take some time to go over the locker problem notes. Then I'll give you time to complete the locker problem assignment that is on Desmos. At the end, once you've completed the assignment, we'll go back over it together and answer any questions that you may have. At the end of the period, we'll go over the learning goals and success criteria again. While we do that, you'll fill out your before you go. Your only homework is to continue working on the Reasoning with Integers study guide and any incomplete assignments that you may have.
Let's take a look now at the locker problem notes. Our notes begin with our learning goals and success criteria. Now, let's talk about what the locker problem actually says. So it says there are 100 lockers in a school hallway and they're all closed. 100 students come through the hallway and start opening and closing the lockers. The first student opens all the lockers. So all of them were closed, now all of them are opened. The second student closed every second locker. So they would close the second, the fourth, the sixth, and so on. The third comes and changes the state of every third locker. Well, changes the state means that if it's open, they close it. If it's closed, they open it. So they would do 3, 6, 9, 12, 15, all the way through. The fourth student changes the state of every fourth locker. So that'd be 4, 8, 12, 16, and so on. The fifth student changes every fifth, and so on until the 100th student changes only the 100th locker. The question is, which lockers are open after all 100 students pass through the hallway? Now let's talk about some strategies that we can use to help us solve this. So first of all, think about it this way. Is there a mathematical formula? Is there any equation that you can think of that we can write to figure out which lockers are going to be open? And maybe you can't. That's fine, so we just move on to the next one. Is there a way we can sketch or draw a graph or something, some kind of visual aid to help us with this? And maybe there is, maybe there isn't for you. If there's not, move on to the next one. Can we break the question down into smaller chunks? So can we look at this, instead of saying 100 lockers, maybe we do 20 lockers or 10 lockers and see if there's any patterns that we can recognize. If there's a pattern we can recognize, then we can try to expand it and make it for the bigger problem and see if it still works. And lastly, is there any actual patterns that just immediately jump out to you? So these are some strategies to consider. Here's a video that shows how we can break this down into a simpler problem.
All right, I'm going to show you one way to visualize how to do the locker problem. So I'm going to start with kind of a simplified visual method. As you can see, I have Uno cards because I always have Uno cards, but I only have 10 of them. So I'm only going to pretend like we're doing 10 lockers. So we have, each of these represents a locker. They're all numbered 1 through 10. So here's what we're going to do. Right now, they are all closed. So face down, you see the Uno, that means that they're closed. So these lockers are all closed. We're gonna simulate what happens when 10 students go through. So we're taking our locker problem and we're simplifying it. Instead of having 100 lockers with 100 students, we're gonna do a smaller problem, okay? Okay, so student 1 is gonna come through. Student 1 will change every locker. So student 1 is going to open every single locker. So now all of these are going to be face up, which means that they are all open. Okay, there's student 1. Okay, next, student 2 is going to come through. Student 2 is only going to change the state of the lockers that have a number that is a multiple of 2. Okay, so it's going to change the state of lockers 2, 4, 6, 8, and 10. When we say change the state, it means that if it was open, it's going to be closed. If it was closed, it's going to open. Okay, so we're going to change the state of locker 2, of locker 4, of locker 6, of locker 8, of locker 10. Student 3 is going to come in. Student 3 is going to change the state of every locker whose number is a multiple of 3. So count by threes. 3, 6, 9. So we're going to change the state. If it was open, we're going to close it. If it was closed, we're going to open it. If it's open, we're going to close it. Okay? So student 4 comes through and will change the state of every locker whose number is a multiple of 4. 4 and 8. So 4 is going to go open. 8 is going to go open. Student 5. Student 5 is going to change the state of every locker whose number is a multiple of 5. So 5 and 10. Notice at this point, we are starting with locker 5. Okay, when student 6 comes through, we're going to start with locker 6. That means that the lockers that have come before are frozen in place. Those are not going to get changed again. Okay? So 1, 2, 3, and 4 are staying exactly where they are right now. They're never going to get changed again because the student number is just going to get bigger. We're never going to hit 1, 2, 3, and 4 again. Okay. All right, so student 5 is going to change the state of locker 5 and locker 10. Okay. I want you to imagine what would happen when student 6, 7, 8, 9, and 10 came through. And then I want you to fill out the next piece of information and tell me which lockers remained open.
So it shows us how we can change the state of 10 lockers and see if we can figure out any patterns that exist. And then we can try to expand it back to 100 lockers and see if that works. So here's an example of this in terms of practice. So it says, let's look at just the first 10 numbers or set 10 lockers. So student 1 opens locker 1. So locker 1 just gets opened by student 1 and that's it. It's never going to be changed again because student 2 is only going to start with locker 2. So student 1 will open locker 1 and it'll stay open. Now, locker number 2, student 1 opens it, and then student 2 closes it. So it's closed. Locker 3, student 1 opens it, student 3 closes it. So it's closed. Locker 4, student 1 opens it, student 2 closes it, student 4 opens it, it stays open. Locker 5, student 1 opens it, student 5 closes it, it's closed. Locker 6, so locker 6 is opened by student 1, closed by student 2, opened by student 3, and closed by student 6. So it's closed at the end. Locker 7 is opened by student 1 and closed by student 7. So it's closed. Locker 8 is opened by student 1, closed by student 2, opened by student 4, and closed by student 8. So it's closed. Locker 9 is opened by student 1, closed by student 3, opened by student 9, so it's open. And locker 10 is opened by student 1, closed by student 2, opened by student 5, closed by student 10, so it is closed. So if we look at it then, we can see that the ones that are open at the end of this are lockers 1, 4, and 9. Well, what patterns do we notice about it? Well, if we notice all of these other ones have an even number of factors, right? In order for it to open and close enough times, we have to have an even number of factors for it to be closed. And notice we have an odd number of factors here for it to be open. So what are the ways that we can get an odd number of factors? So we said that these were the ones that are open. And in order for them to have an odd number of factors, they need to be perfect squares because we need to have some kind of factor that's multiplied by itself, such as 9 is 1 times 9 and 3 times 3. But we don't duplicate 3, so we end up with an odd number of factors here. So therefore, it is open at the end. So they need to be perfect squares. Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click start the activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google. Let's talk now about how to complete the locker problem assignment. So if we look at the top of the page, we have our learning goals and success criteria here. If you scroll down, it has a link to the Desmos activity. So we'll go ahead and click on that. And it takes us to a page that looks like this. We're going to go ahead and click start the activity. It begins with our learning goals and success criteria. We'll go ahead and click next. It has an introduction video that I'd like you to watch.
Hello? Hello? Come on, y'all. Stop playing. Anybody there?
I've been in here 20 years.
Hey, stop playing, y'all.
Oh, son, you don't know my voice. Let's go.
I don't hear anything. I might be having a nervous breakdown. I'm gonna be all right. Go home, get me some sleep. I'm gonna be right back on top in the morning.
I see you gonna need a little more convincing.
Then it gives the locker problem. It says there are 100 lockers in a school hallway and they are all closed. 100 students come through the hallway and start opening and closing the lockers. The first student opens all the lockers. The second student closed every second locker. So he would close the second, the fourth, the sixth, and so on. The third student changes the state, meaning if it's open, they close it. If it's closed, they open it. So they change the state of every third locker. So 3, 6, 9, etc. The fourth student does the fourth one. So does 4, 8, 12, etc. And the fifth one changes the state of every fifth one, and so on until the 100th student changes the state of just the 100th locker. At the end of it all, which lockers are still open? Things to consider. Is there a mathematical strategy that comes to mind that could help you solve this? Is there a way to draw a sketch or drawing that could help you complete the problem? Can you break the question down into smaller chunks? So instead of doing 100 lockers, could we do 20 lockers or 10 lockers or even 5 lockers? Are there any patterns that immediately jump out at you? So which lockers are open after all 100 students pass through? So you'll go ahead and work this out and then put this in there. So let's say that I found that lockers, 1, 4, 7, etc. were open. So I'll put that in there. And then what pattern do we notice? Well, if this was the pattern, which it isn't, I would say it's every 3 lockers that are open. So you'll go ahead and state which lockers are open and then what pattern we notice. Now, there's some extensions. So instead of there being 100 lockers, once we find the pattern, it should be pretty easy. But instead of there being 100 lockers open, now maybe it was 200 lockers. Now we'll decide which lockers will be open. Suppose there are 100 lockers, which ones are changed exactly twice? And then which ones follow these 2 patterns that are given? At the very end, there's a closing video for you to watch, and I hope you enjoy it. Once you're done with this assignment, go back to your Google form, click Next, and fill out your Before You Go. Once you're done with your Before You Go ahead and submit your work on Google Classroom.
Sorry, I can't come.
Nice Indian beads, buddy. What's with the vest? I don't want them. Take the kid. Can I join your Indian club too, please?
Looks like Chingachidork is getting shoved into his locker again. See you dressing up like an Indian gets you? Hey, where you going?
I'm gonna help him out. Hey! What do you think you're doing?
Talking to us, punk?
I can't watch this.
Let him go or face the consequences. Yo!
Sorry about that, Norm. I thought it'd work. That's okay, Ben. I appreciate the effort. You know, it's not so bad in here. It's kind of peaceful. Yeah, it's amazing how you get used to it after a while. Hello? Anybody out there? Can someone please help us?